Hello everyone. So in this video we'll be discussing about resonance effect. Resonance effect is also known as mesomeric effect. Now let's see what is the definition of resonance effect. So it is basic the polarity which has been created in the molecule due to the interaction of lone pair of electrons and the pi bonds. So there might be a polarity created due to the interaction of the lone pair of electron with the pi bonds, or there might be an interaction between the two pi bonds. So these are the three different ways in which the polarity has been created. So the pi bond, if it is shifting to this carbon atom, then there will be a negative charge created, a polarity has been created. Similarly, if it is having a lone pair of electron and that is shifting to the next carbon atom, then it is creating a charge separation, or it is a pi bond interaction. So these are the three different ways in which a polarity has been created. So basically a polarity created due to the interaction of the lone pair of electron and the pi bonds. Okay, so now we have two types of resonance effect. One is plus R effect and one is minus R effect. So what is this plus R and minus R effect? Actually, if you see, they are certain group which will be attached over the benzene ring. So suppose if these groups are basically electron donating group, they are going to donate the electron towards the benzene ring, then they will create a plus R effect. So these are the examples. So this is a transfer of electron away from an atom or substituent group attached to the conjugate system. So as we know, the conjugate system is a benzene ring. So there is a pi electrons and they keep delocalizing. Okay, and then these group, okay, these are called as electron donating group. They are going to donate the electron to the benzene ring. Okay, and due to which what happened, there's an interaction between the lone pair of electrons and the benzene ring, and there is a creation of polarity because of the interaction of the lone pair of electron and the conjugate system. So now let's take an example of an plus R effect. These are the examples. If electron donating group is attached to the benzene ring, they lead into plus R effect. So we will take an example of aniline. So aniline is basically when NH2 attached to the benzene ring. Now here we know that aniline has a lone pair of electron, correct? And what is a benzene ring? So it has an alternate single and pi bonds, okay, single bond and double bond. So alternate sigma bonds and pi bonds, and this is keep delocalizing. It's not a fixed position. So there is an interaction between this lone pair of electron on the nitro group, okay, and also this pi electrons of the benzene ring. So due to which the polarity has been created, and that's only called as resonance effect. And plus R effect is basically if this group is giving, the group which is attached to the benzene ring is giving the electron to the benzene ring, then it shows a plus R effect. Now let's see how the resonance is taking place in case of aniline. So there are 5 steps to be followed, and it's very important as per the exam. So kindly pay attention. So first of all, I will make a note of the carbon atom so it becomes clear. So carbon 1, carbon 2, carbon 3, 4, 5 and 6. So we need to shift the electrons, okay. So this lone pair of electron is going to first shift to this carbon atom, that is between the nitrogen and the first carbon atom. So if you see the first carbon atom, now if it is shifting, then it will have, already it is having 4 bonds and now it will have 5 bonds which will become unstable. So in order to reach its stability, definitely this particular bond will shift. Okay, so this bond will shift to the carbon 2. So this is the first shift, okay. This is how you're supposed to show. So now this is the next structure, how it is going to be. So the same benzene ring, okay, and then nitrogen, if you see, now it is creating a double bond, and now nitrogen gets a positive charge. Why nitrogen gets a positive charge? Because nitro group NH2, the amine group here, it is giving the electrons to the benzene ring. So whenever it is giving the electron, it gains a positive charge, and benzene is receiving the electron from this group, so therefore it gets a negative charge, and therefore polarity has been created because of the interaction of the lone pair and pi bonds. So that's only called as plus R effect, okay. So now after giving the electron, so it gets a double bond, okay, and then this particular bond is not disturbed, so write it as it is. Now what has happened? Now you can see that this pi electron is shifted to carbon 2. So at carbon 2, can I write a negative charge like this and put that means the electrons are shifted to this position, that is carbon 2. From carbon 1, the electrons are shifted to the carbon 2. 3, 4, 5 and 6. Okay, so next what's going to happen, this bond is going to remain as it is. Okay, now there is a shift again going to take place, that is from carbon 2 you have to show this negative charge between carbon 2 and carbon 3. So when it is shifting here, then it will become again unstable because carbon 3 will be having 5 bonds. So for this pi electrons of carbon 3 and carbon 4 will shift to the carbon 4. Okay, there is a 2 shift. Okay, one from 2 to 3 and now from 3 to 4. Okay, so this is how the next structure is. So now let's go with the next resonating structure. Okay, let's make sure that remaining everything right as it is. Okay, now what is not disturbed? So this is not disturbed. Now you can see that from 2 to the electrons from the carbon 2, it is shifted between carbon 2 and carbon 3. So can I put a double bond there? Yes. And then you can see that this between 3 and 4, the electrons, the pi electron shifted to the carbon 4. Okay, so there we can just write it like this. So this particular carbon 4 electrons I can show here. So now from carbon 4 it will be shifting to carbon 5 and from carbon 5 it will shift to carbon 6. Correct? So next shift is between carbon 4 and carbon 5 and next shift will be between 5 and 6. Okay. So next resonating structure, if you see. So now NH2 with positive charge as it is, this bond not disturbed, so write as it is. Now you can see between 4 and 5 I will be getting a double bond and at 6th position I will be having this electrons. Okay, that is the lone pair of electron which is shifted here. Now ultimately you have to stabilize this positive charge and this negative charge. How do we stabilize? So next shift will be, this is the final shift. So from here, that is carbon 6 to carbon 7, the shift is taking place and I will satisfy this positive charge like this. So as a result, nitrogen, NH2 as it is, so you get back your original structure, that is aniline. Okay, so make sure that from where you started the structure, it has to come back in the same way and also it should not have any positive or negative charge. So this is the resonating structure of the aniline. Okay, and this is showing a plus R effect because the nitro group, NH2 group, that lone pair of electron or nitro group is polarizing. Okay, it is there is an interaction between the lone pair of the nitrogen group and the pi electrons of the benzene ring, and as a result the polarity has been created. So polarity is nothing but this positive negative charge which has been created by them. Okay, so this is plus R effect. Now let's go with the minus R effect. So in case of minus R effect is just an opposite of plus R effect. So here what happens, the electron is getting withdrawn. Okay, the electron is being pulled from the benzene ring, okay, by the electron withdrawing group. So all these are the example for electron withdrawing group. So the transfer of electron is towards the atom or substituent group attached to the conjugate system. That means from the benzene ring the electrons are pulled by these group. Their electron withdrawing group is creating a minus R effect. Now let's take an example of this example also of minus R effect. So I will take an benzene ring. Okay, and I will introduce a nitro group to this. So nitro group is a strong electron withdrawing group. So what's going to happen, this oxygen atom is more electronegative. It's going to pull the electron from the nitro group, and nitro group again being more electronegative than this carbon atom, okay, than this benzene ring. So it's going to pull the electron from this pi electron. So this is the first structure. So followed by this, the next resonating structure. As usual you keep this because it's not disturbed. Now what happened, nitro group will get a double bond because here already one bond pi bond is shifted here, and this oxygen not disturbed, and this O will get a negative charge. So 1, 2, 3, 4, 5, 6. Okay, that lone pair of electron you can write, and it gets a negative charge because it's an electron withdrawing group. And what charge will the benzene ring get? It gets a positive charge. Okay, where does it the positive charge? From where the electrons, pi electron was taken. So that carbon, it gets a positive charge. If you want, you can number it 1, 2, 3, 4, 5 and 6. So you have got at second portion a positive charge. Okay, and this pi bonds not involved, so I'll write it as it is. Okay, so now to satisfy this positive charge, what happens? So this particular pi electrons will shift to this between carbon 2 and carbon 3, so that it will satisfy this carbon 2's positive charge. Okay, so after this, next structure, as usual, nitro group with oxygen and with O negative charge. Okay, and then this pi electron you can write as it is, carry forward, and then since this bond is shifted here, it will be here between carbon 2 and carbon 3, exactly at carbon 4. Now what is going to happen? It has lost its electron, right? So it gets a positive charge. Exactly at carbon 4 it gets a positive charge. Now to stabilize this positive charge, this pi electron will shift. Okay, so next to stabilize that positive charge, so first you write down whatever is not involved in the movement. Okay, so after that what is going to happen? So this positive charge is stabilized by this bond. Okay, so I will show the shift here. So after showing the shift, you can just make a bond between the carbon 4 and carbon 5. So exactly at carbon 6 you will get a positive charge now. Is that clear? So now next is what? To satisfy this positive charge at carbon 6, this negative charge on the oxygen will shift here. Again, now this pi electrons, okay, of the nitrogen carbon, between nitrogen carbon, will shift back here to stabilize this positive charge. As a result, this positive and negative is stabilized, and you will get a stable nitrobenzene group. So nitrogen with oxygen. Okay, so you hold that positive negative charge is stabilized. So this is how you're supposed to do the resonating structure of a nitrobenzene ring. Okay, so anyways, resonance effect. So actually a polarity, okay, has been created between the lone pair of electron and the benzene ring. So there are two types, one is plus R and one more is minus R. So when do we exhibit a plus R effect? So whenever there is an electron donating group, then it is plus R. Whenever there is an electron withdrawing group, there is a minus R effect. And then if it is a plus R effect, so the group which is attached to the benzene ring is going to give the electron, and therefore it gains a positive charge. And benzene ring is going to accept the electron, therefore it gets a negative charge. So you just make a note of this. Okay, this is very important. But whereas in case of minus R effect, so we have taken an example of nitrobenzene. So nitro group is more electronegative. Okay, so it's going to pull the electron from the conjugate system. So therefore this nitro groups gets a negative charge and the benzene gets a positive charge. So this is the difference. Okay, so thank you so much.